Hi students, this is AJ sir. Let's study 10th standard ICSE Math, chapter 12, Reflection. Imagine that on a graph there is a point which is minus 3, 4. Minus 3 is the abscissa on the x-axis and 4 is the ordinate from the y-axis. So this is the x-coordinate and the y-coordinate. Here's minus 3, 4. What if this y-axis acted like a mirror? Then you would see its image on the right hand side, and that would be somewhere around here, which would be called 3, 4. So even without plotting the graph, even without drawing it, you should know the trick that whenever there is a reflection along the y-axis, you simply have to change the sign of the x-coordinate. That is, minus 3 will become positive 3. But y-coordinate 4 will remain as 4, as you can see from this example. On the other hand, let's take the example of point B, minus 2, minus 3. If the x-axis acts like a mirror, where would the image be? Take a guess. It would be somewhere around here. This is the object and the image. This is the mirror. And the coordinates here will be minus 2, 3. So the trick here is, if there is reflection along the x-axis, then the sign of the y-coordinate changes. Minus 3 became 3. But the x-coordinate remained the same. Minus 2 is minus 2. So it's always the reverse. On the other hand, what if the reflection was along the origin? What if there was a mirror passing through the origin for point A? Then the image will be right here and both the signs will change. Minus 3 will become 3 and 4 will become minus 4. Also remember that every line on the graph has an equation, a linear equation. The equation of the x-axis is y is equal to 0, and the equation of the y-axis is x is equal to 0. Again, the reverse. Exercise 12a, cancel question 1 and question 2. Also cancel questions 3.1, 4.1, 5.1, 6.1, 7.1. Question 8 and 9 are also cancelled. Also question 12 and 13 are cancelled, and so is question 16. But if you wish to do them, you may. Let's do question 3.2. State the coordinates of the following points under reflection in x-axis. So whenever the reflection is in x-axis, which sign changes? The x-coordinates or the y-coordinates? The y-coordinates. So the answer is minus 5, minus 4. So you see, even without plotting the graph, even without visualizing anything, we can find the answer by knowing the trick. Here the reflection is in the y-axis, so the x-coordinates sign will change, so the answer will be 1, 0. What if the reflection is in the origin? Then both the signs will change, so the answer will be 2, minus 7. What if the reflection is in x is equal to 0? Well, x is equal to 0 is nothing but the y-axis, and reflection in y-axis means change the sign of the x-coordinate. But 0 has no sign, so the answer will be same, 0, 5. That's something interesting. 0, 5. Look at this graph. 0, 5 would be somewhere around here. This is 0, 5. This is the object, let's say. Now, if I want the image in the y-axis, so y is acting like a mirror, where would the image be? Well, it would be exactly there itself. It will be coinciding with the object. So we say that this point is invariant. That is, it is unaltered under the given transformation. It is invariant in y-axis. Of course, if I say that the x-axis is the mirror, then it won't be invariant. Then the image will be somewhere around here, which will be 0, -5. Let's take another example. This one, 5, 0. Where is its reflection in the x-axis? Here itself. This is the image as well as the object. I can call this A, and also I can call it A dash. That is the image. So I say that A point is invariant in the x-axis. That's why this answer was same, 0, 5, because it was invariant, although that was not asked in the question. Just an observation. Now 7.2, reflection in line y is equal to 0. Well, that's nothing but the x-axis, and reflection in x-axis means change the sign of the y-coordinate. So the answer is 8, 5. So just write all these answers and do the remaining ones for homework. Next, let's do the 10th sum. The point is P, A, B. It is first reflected in the origin. So we get some answer, which will be -A, -B, because both the signs will change. After that, it is then reflected in the y-axis to become P dash. Well, y-axis means the x-coordinate will change. So now it will become A, -B. But the final answer is given, which is supposed to be 4, 6. Evaluate A, B means find the values of A and B. So basically they're asking us to find the original point. They've got the final image, and we have to find the original point's coordinates. So first, the original point was A, B. We don't know the values. Reflecting it in origin means signs of both will change. I have just named it as P double dash, just to distinguish it from P dash, which is the final image after transforming it in the y-axis. Well, y-axis means the x-coordinate sign will change. So it's A, -B. That is our answer. But they have given the values of this point, which is 4, 6. This means that A, -B is equal to 4, 6. So by comparing, A is equal to 4 and -B is equal to 6. So shifting the minus sign, B is equal to -6. So what's the original point now? It's 4, -6. That's the original point. Let's have a look at it in some graph now. The original point I said is 4, -6. Where would it be? Where would you locate it? Do you know how to plot a point? 4, -6. Where is it? It'll be somewhere here, isn't it? 4, -6 is P. Then we did a reflection in origin. So we'll get it as -4, 6. So somewhere around here. And I had called it P double dash, by the way. And then we reflected it in the y-axis. So obviously the image will be here. And now we'll call it (4, 6), which is here, P dash. So first transformation and second transformation, fine. But what if they ask you, give a single transformation from P to P dash? That is nothing but reflection in x-axis. So remember, reflecting in the origin and then the y-axis is the same as reflecting in x-axis. And vice versa, if I say reflected in the origin and then the x-axis, that is same as reflecting in the y-axis. Or even if I change the order, first reflect it in the y-axis and then reflect it in the origin, still you'll get reflection in x-axis, and so on. So what I mean is, reflection in the origin and then the y-axis is equal to reflection in the y-axis and then the origin, which is equal to reflection in the x-axis. They are all equivalent, the final answer will be same. When you will do more reflection sums, this will be very evident for you. I can also say that reflection in the origin and then the x-axis, or reflection in the x-axis and then in the origin, will give me the same answer as just doing a single transformation of reflection in y-axis. Now 14.1. The triangle ABC, where A, B and C are given. No need to plot it. We can do it without plotting. It is reflected in the y-axis, A dash, B dash, C dash. Then they are reflected in the origin, A double dash, B double dash, C double dash. So first they want the coordinates of A double dash, B double dash and C double dash, the final answer. And they want a single transformation which is equivalent to reflecting in y-axis and then reflecting it in origin. Can you tell me the single transformation which is equivalent to origin plus y-axis? Reflection in x-axis. That's right. So, first of all, reflection in y-axis, change the sign of x-coordinate, and then reflection in origin, change both the signs from here onwards. By the way, if I would have done reflection in x-axis directly, I would have got the same answer as this. You know, reflection in x-axis is nothing but changing the sign of the y-coordinate. So this will become 2, minus 6. Check. That's the answer, 2, minus 6. So similarly, get the value of B dash and B double dash, and then C dash and C double dash. And then the single transformation is reflection in x-axis. You can write it in English as well. Next, the 18th sum. The point on reflection in a line is mapped as 5, 0. So I see that the sign of the x-coordinate is changed. So clearly the reflection is in the y-axis. Even here, the sign of the x-coordinate has changed between the object and the image. So definitely the transformation is in the y-axis. So name the line of reflection. Answer, y-axis. By the way, if they would have asked the equation of that line, what is the equation of y-axis? Well, it's x is equal to 0. Next, write the coordinates of the image of this in the same line, that is the x-axis, the y-axis. Well, change the sign of the x-coordinate, so that's minus 5, minus 8. That's the answer. So with this we finish the A exercise. Now let's do the B exercise. First sum. In this exercise, graphs are required. Take some cancellations. Cancel 2.3, 2.4. Cancel question 3, question 5. Cancel 8a and 8b. And cancel 16.3. In the first sum, A, plot A, B on a graph paper. They have even given the scale to be used. I have not really focused on the scale, but you should. So here's my plotting, A and B. Next they have said reflect it in the x-axis. So x-axis is the mirror, so reflect them. And of course x-axis is the mirror means the y coordinates will change. So this way you will not make any silly mistake. And then they asked us to join it, and they've asked us the geometrical name of this figure. It's not a parallelogram because these two sides are not parallel. It's a quadrilateral, of course, but what's so special about it? Well, I see that these two lines are at least parallel and these two sides are equal. So it's an isosceles trapezium. Next, they've asked us to measure the angle of ABB dash. ABB dash means this angle. So remove your protractors. You all know how to measure it. Clearly it's an acute angle, so make sure your value comes less than 90 degrees. And the answer is, well, should I tell it? Or would you like to search first? Pause it and do it on your own. Okay, the answer is 45 degrees. Here we go. And next they have asked for the image A double dash when A is reflected in the origin. So if you look at the graph, the answer will come somewhere here. which is minus 3 comma 2. But even without the graph, you know that you just have to change both the signs of the x and the y coordinates and you'll get the answer. And finally, they've asked for the single transformation that maps a dash to a double dash. Well, a dash is here and a double dash is here. So what is the transformation we are doing here? We are using y-axis as a mirror from a dash to a double dash. So definitely the transformation is reflection in y-axis. Now question 2. There are these points 3, 0 and 1, 0 are invariant points under reflection line L1, and these points are invariant on reflection in line L2. They've asked us to identify the lines L1 and L2. Well, definitely one of them will be the x-axis and the other will be the y-axis. But how to identify it? One way is you just roughly draw a graph and figure it out, or you remember a trick. If the y coordinates are 0, that means they are lying on the x-axis. So the x-axis is the mirror here and they are invariant in x-axis. And here the x coordinates are 0. That means they are lying on the y-axis. You can actually plot it and check this. That means that they are invariant in the y-axis. So L1 is the x-axis and L2 is the y-axis. But they've asked for the equations also. So we write the equation. The x-axis equation is y is equal to 0. And the y-axis equation is x is equal to 0. So write the axis also. Roman number 2 is write down the images of points P and Q on reflection in L1. L1 we have already identified as the x-axis. So we'll have to change the which coordinate? The y coordinate. So we get the values of P dash and Q dash. Next, question number 6. A point P is reflected in the line x is equal to 2. Now that's something very unique about this sum. Because now the reflection is not happening in the x-axis or the y-axis. It is happening along the line x is equal to 2. So you'll have to use a graph to figure it out. At least a rough graph. So P is minus 2, 3. So that will be somewhere around here. Here we have minus 2, 3, P. And the mirror is x is equal to 2 line. Now remember, the y-axis is x is equal to 0 line. X is equal to 2 line is this one. This line is called x is equal to 2. Remember, whenever the equation is x is equal to something, then it has to be perpendicular to the x-axis and parallel to the y-axis. If the equation was y is equal to something, it will need to be perpendicular to the y-axis that is parallel to the x-axis. So now this is the mirror. Where will the image be? Somewhere around here, isn't it? But what are the coordinates of this? This was what? Minus 2, 3. Okay. If this was reflected in the y-axis, we know that the sign of the x-coordinate would change. But the y-coordinate would remain the same, isn't it? Same applies here as well. Here the y-coordinate will remain 3. The problem is with finding the x-coordinate value here. What will be the x-coordinate? Where will it lie? Well, let's check out the distance. From here to the mirror, what is the total distance? It is 1, 2, 3, 4 units. So go 4 units further behind the mirror. 1, 2, 3, 4, which comes up to 6. So that's 6, 3 is the answer. So that's why you'll have to make a rough graph to figure out this answer. 6, 3. Next, let's do the 10th question. There is a point P. It was reflected in the origin. Okay, so that's minus 5, minus 3. Fine. Now if M is the foot of the perpendicular from P to the x-axis, find the coordinates of M. Well, for that you'll have to draw a graph. So let's start. This is the graph. and this is point P here, which is 5, 3. And the reflection in the origin is minus 5, 3, which is here, this one. This is P dash. This is reflection in the origin. Alright. So draw perpendicular to the x-axis and call it M. So what is the coordinate? What are the coordinates of this point? It's lying on the x-axis. That means the y-coordinate will be 0. So it's 5, 0. What is this point called? 5, 0. Next, they've asked that if N is the foot of the perpendicular from P dash to the x-axis. Okay. From P dash, draw perpendicular to the x-axis. Clearly, this is perpendicular to the x-axis. What are the coordinates of this point? Well, again, it's lying on the x-axis, so the y-coordinate will be 0. That's the rule. So the answer is minus 5, 0. That's the answer of this, minus 5, 0. Next, they've asked us to join all 4 points and name this figure. Well, it's a parallelogram because the opposite sides are parallel to each other. So it's a parallelogram. They've also asked us to find the area. There are 2 ways. One is find the area of the triangle and area of this triangle and add them. That's double of the area of one triangle. An area of triangle is half into base into height. If you take this as the base, which is 5 plus 5, 10, and this as the height, which is 3. So that's 5 into 3 and double that. So total answer would be 15 plus 15, 30 square units. See, half into base into height. Base I said is 10 and height is 3. Cut 5. So 5 into 3 is 15. That's one triangle. 15 plus 15 is 30. But I'm going to use a direct formula. Area of a parallelogram is the base into the height. This is the base, which is 3 units, and the height is always perpendicular distance between 2 parallel sides. So this is the height, which is 10 units. So 3 into 10 is 30. And I won't write square centimeters. In fact, this 1 unit is not really 1 centimeter, it's 2 centimeter. So let me not use centimeter unit here. I'll just say square units. If you want to use a triangle method, you can. That is half into base into height for one triangle, half into base into height for the other triangle, and add them. Next, the 13th sum. P and Q have coordinates 0, 5 and minus 2, 4. Okay. P is invariant when reflected in an axis. Which axis? Well, you know the trick. If the x coordinate is 0, it's invariant in the y-axis. That's the answer. B. Find the image of Q on reflection in that axis. That is on reflection in the y-axis. That means change the sign of the x coordinate. So the answer will become 2, 4. C. 0, k on reflection in the origin is invariant. What point in the graph is such that even after reflection in the origin, it remains invariant? That is, the answer doesn't change. That is, the object and the image coincide. Well, there is only one such point, the origin itself. So 0, 0 is the answer. That means k's value is 0. You see, if I have a point out here, 0, 0, and if I say, okay, where is the image when you reflect it along the origin? What's your answer? Same point, right? 0, 0. It's invariant in reflection in origin. And D, write the coordinates of the image of Q. What was the image of Q we had got? 2, 4. But that was in the y-axis. But here they have asked the image of Q reflected in the origin and then reflected in the x-axis. Well, together that would just simply mean reflection in the y-axis, but we'll do it a long cut way. First of all, reflection in the origin, change both the signs, and reflection in the x-axis, change the sign of the y-coordinate. So that's your final answer. Next, the 15th sum. Using a graph paper, plot the points A and B. Okay, done. Next, reflect it in the origin and write the coordinates of A dash and B dash. Okay, here's A, here's B. B's reflection in the origin is B dash, A's reflection in the origin is A dash. We could have got the answers even without drawing, but they insisted that no, you draw the graph. So done. And what's this geometrical figure? It's a parallelogram. So far so good. But now they've asked for the perimeter. The perimeter is nothing but the sides added, sum of all the sides. This plus this plus this plus this. If it was a rectangle, we could have simply used the formula 2 into length plus breadth. In fact, we can use that even now because the opposite sides are equal. So if I can know this, oh, this is easy. It's 6, isn't it? 6 units. In fact, in this case, I can even say 6 centimeters, but we'll stick to units. Notice how I've used a different scale out here. So this is 6, this is 6. But how do I find this? Now don't take a ruler and draw this. We'll have to find this hypotenuse using Pythagoras theorem. How much is B dash, by the way? Count. Isn't it 8 units? And this is 6 units. And this is a right angle triangle. So can't I find the hypotenuse with the help of Pythagoras theorem? That is, hypotenuse square is equal to 6 squared plus 8 squared. So that's totally 100, and square root of 100 will give me A dash B, which is same as AB dash. So that's 10 units. So this is 6, this is 10, this is 6, this is 10, and that's how I add them and get the perimeter of the parallelogram, like this, which comes out to 32 units. Also, I prefer this scale rather than this huge one, because then it becomes a headache to draw a straight line from P to N. You know, you'll require a very big ruler so that you don't mess up in the midway. Finally, the 16 sum, use a graph paper. Okay, they've given some scale to be used, so make sure you use that scale. I'm using the liberty not to. Plot the points O, A, B and C. Done. Reflect A and B, only A and B on the y-axis. That means I'll have to change the x coordinates and plot them. And then connect them together and name the figure. So do this on your own. Pause the video and do this on your own. Let's see if your figure is the same as the one I will show right now. Here, did you get it like this? No? Then you'll have to practice more. They have asked us to name this figure. Well, it's 1, 2, 3, 4, 5, 6 sides are there. So it's a hexagon. Not a regular hexagon, of course. It's a hexagon, 6-sided figure. But more specifically, it's called an arrowhead. So that's the answer. And remember, whenever you do something on graph, you have to mention in every sum on graph paper. Hi students. If you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.